Alright, for the second part of the density lab now, to actually calculate the density of metal, you'll notice I have the spreadsheet all set to go from my other calculations for the pycnometer. So now I'm actually going to go ahead and do the second part with all the calculations and the uncertainties. Probably go a little bit faster this time. One of the things that I had to record was the mass of the metal plus pycnometer. And then, of course, I'm going to have an uncertainty on that. And I'm going to also put this in to save me some space. I think I'm just going to actually use percentage when I mean percent uncertainty, and for absolute I'm just not going to type ABS. I'm just going to leave that one as D mass M plus P. And the other thing that I recorded in the experiment was the mass of the metal plus pycnometer plus water. And of course I'm going to need to put in some uncertainty calculations for that. And we can do one for the percentage one. Alright, so there's going to be more things I'm going to add in, but we'll just start with this for right now. Again, I'll just do it for trial 1, but once I go ahead and do it, I could do it for trials 1 through 5. So let's just say that I got for this one, let's see, 36.3 grams, mass of the metal plus the pycnometer. And I know that I'm going to use the equal sign, that the scale can be off by 0.01 grams, and I can go ahead and get the percentage uncertainty by doing this sort of thing. Okay, so I just went ahead and got my uncertainties on that value. And let's say my other experimental value, this thing comes up to, let's say 45.3 grams. Again, I use the scale to do this, so my uncertainty for all this is going to be 0.01, the absolute uncertainty, and I can go ahead and get the percentage of this thing, just like before. Alright, so now I actually got to do some calculations, and I'm going to have to do some panning, and this is going to take a little bit more time. The first calculation that I can do is get the mass of the water. Now, I don't necessarily have to get the calculations in this order, but I'm going to follow the order. I do believe it's the same order as the lab handout that I'm giving you. But anyway, mass of the water is going to be, well, it's the mass of everything minus the mass of the metal plus the pycnometer. So the only difference between these two values is it's got water added in. I'll do it as a formula. It equals this value minus this value. And of course, there is uncertainty on that. So since this was a subtraction calculation right here, I have to add the absolute uncertainties of the other two. So it'll be that value plus this value. And I can go ahead and do what percentage is 0.02 of 9 to get the percentage uncertainty. Divided by 9, or the cell, I'm sorry, times 100. Okay, so there's my first calculation done. The next calculation that I want to do is the volume of the water. And that's going to be the mass of the water divided by this density that I had from before of the water. Remember, this was the recorded density of the water that we had. And then I want to lock with the dollar signs in my calculation because I want to use that density for everything. I'm going to do equals mass divided by, click on this density, but I'm always going to keep that density for all my calculations. So I got to put the dollar signs in. I'm going to press F4 and it puts it in. And we have, of course, uncertainties on that. Well, since this value came from division, I need to add the percent uncertainties of the numbers that I used. So it equals the uncertainty percentage on that value plus whatever the uncertainty on this density was. Remember that this was a pretty accepted value, so it's just going to be 0. And I can back calculate to get the absolute uncertainty. I can do this number but change it into a decimal, so I got to divide it by 100, times it by the actual value. And now I've got all of those things in there. The next calculation that I have to do here then is the volume of the metal. Well, if I already know the volume of the pycnometer from before, and I know the volume of the water, I can subtract off to figure out how much the volume of the metal plus the volume of the water has to equal the volume of that pycnometer. So it equals whatever this number is, and again, I want to lock that value with the dollar signs, pressing F4, because when I do the fill downs, I don't want that to pull down any other cells, and I'm going to subtract off this value of the water. We have to do uncertainties on that. Since this number was gotten by subtraction, I can go right into the absolute uncertainties, and I just add the two of the numbers I used. So let's see, the absolute uncertainty is this, which will never change, so I'm going to lock it with dollar signs, plus my absolute uncertainty in the volume of the water. And I can then change this into percents. One of the last things that I have to then do is to get the mass of the metal. So I will place those in. And what I have to do from before, let's see if I can slide this over. I have the mass of the metal plus pycnometer way over here, and I have the mass of the empty pycnometer here. It would probably be best to get an average value. Right now I'm going to tell you that the average of those, actually let's just do it this way, equals average. I'll just highlight those three numbers. There's my average value for mass of the pycnometer. I'm going to slide this over. One nice thing in Excel is if I slide this over, it still knows all the cells that referenced it are okay. And let's see, average absolute, and then we can do the average of the uncertainty here. So I probably should have done that before. Well, the average this has to be 0.01. I can actually type it out. Oops, got to type in actual word average. A little trouble spelling. Okay, and the same thing here, equals average, open parentheses, and I can do this. Alright, so if I need to reference those now, I should be okay. Alright, so I'm going to take the mass of everything minus the mass of the water minus the mass of the pycnometer. And I can get the mass of the metal plus pycnometer minus the mass of the pycnometer. So here's what we'll do. This value equals the value of pycnometer plus the metal minus, let's take the average value for the mass of that pycnometer. And there you see it's 26.1. So I'm going to then, of course, get my uncertainties on this. Since this was a subtraction number, as you can see right here, that was gotten by subtraction, for the absolute uncertainty, then in the mass of the metal, I have to add the two numbers I use. So it equals, it would be the uncertainty in the mass slide it over. It would be the uncertainty in the mass of the metal plus pycnometer plus the uncertainty, the average uncertainty in the mass pycnometer. Again, there's only one value for this, and I want to lock that for my fill down stuff, so I'm just going to hit F4 to lock. And it puts it in there, and it jumps me over here, and now I've got the mass of the metal is that value. The percentage, again, I can just use by figuring out what percentage is this. That times by 100. And I'm almost done. Now I have a mass of the metal, and I have a volume of the metal. So if I want the density, it's just going to equal the mass of the metal divided by the volume of the metal. And of course, I got to get my two uncertainties in here. Since this was obtained from division, I need to first get my percentage. I have to add the percents. So this is going to equal the percent error in the mass of the metal plus the percent error in the volume. I'm sorry, percent uncertainty in the volume of the metal. And there is my percent uncertainty. And if I want to figure out what the absolute is, I change this back to a decimal, and I times it by the actual. Alright, so now I've gone through this, and you can see it doesn't all fit on the screen here. I can pan over all those calculations, and that seems like a lot of work. But now I've got to do the exact same stuff for trials 2, 3, 4, and 5. Should go a lot quicker here. So what I will type in, let's just make up some numbers that I got. Let's just say and the other one would have been here. Okay, and now all I have to do is do some fill downs and I'm done. So I'll just highlight this. I just want to make sure that 0.01 carried down, and it did. And let's see if I can pan this over a little bit. Almost get the whole screen. Can't quite get it. Alright, so I will just do what's on the screen, but you can actually fill down the whole thing. So this is what I can get, so I will fill those in. Just make sure all my errors and stuff look normal. They do. Something looks kind of funny here. A15 minus A10. I'm guessing I did not lock something when I did before. Okay, so when I had the average p-value here, the average value of the picnometer, I needed to actually lock that value. So I'm just going to actually add my cursor to this. If you forget to do this, it's actually really easy to do. I needed to lock that A6. There's only one value here. This needs to have dollar signs around it. So you can type it in, or I can put the cursor there and just press F4 and hit enter. And what I would need to do now is I would have to fill down this box again, and I should be able to get rid of all that. There we go. And now I haven't finished completely everything. So I'm just going to fill down the rest. And now I've got the values of everything. I've got my density of the metal for all 5 trials. I've got the uncertainties, and it's all set to go for anything I want to do. Just a reminder, this isn't a very clean looking spreadsheet. People aren't going to really know what these things mean up here. There's too many decimals and stuff like that. So we want to definitely clean this up before we import it into Word or any report that we would want to use.